So this video is for all of you who are struggling to interpret what my atomic structure notes were actually trying to mean. So these are all the things that you really need to be aware of for atomic structure in the AQA syllabus, but it's also applicable to OCR and Edexcel. Now getting straight into it, you can see I have drawn a questionable diagram of an atom. And then there we've got the central part, which is the nucleus, and that contains protons and neutrons as the subatomic particles. We then have electrons that float around the edge. Now, a lot of the time students really struggle with actually understanding what each of those subatomic particles actually mean. So electrons, these are pretty much the most important part of the atom because it determines the chemical properties, or at least the outer shell of electrons determine the majority of the chemical properties of the atom. Now, the neutrons determine what type of isotope it is. It basically contributes mass. How heavy is our atom as a whole? And then the protons determine the element that they actually are. So these contribute the positive charge of the atom, whereas the electrons are negatively charged. And if we change by one proton, we will go up to a different element. So it will no longer be the same element. If we change neutrons, it will still be the same element, but it's just a different isotope. And if we change the number of electrons, then it turns into an ion form of that element. So it won't be the atom anymore because we'll have an unbalanced charge of either more electrons or more protons, depending on if we've lost or gained electrons. So this diagram here I drew to kind of represent how you're taught it at GCSE, where the particles are running around the outside of the nucleus, so outside in shells, in rings on their own. Now, in actual fact, electrons don't behave like discrete particles, so they're not exactly like people running around a track. They're more like a wavy particle, so they don't behave exactly like a wave, and they don't behave exactly like a particle. So the way that I imagine it almost being is a bit like a boat on the sea, but even that's probably too discrete to describe what an actual electron behaves like. In those shells, we've got orbitals, and each orbital has a maximum of 2 electrons in the orbital, and that's where the highest probability of an electron residing is. Now, the number of orbitals per subshell, so the S, P, and D subshells, so we have individual orbitals, but per subshell we have one S orbital. The P subshell consists of 3 P orbitals, and the D subshell consists of 5 D orbitals. Now I've only drawn 2 of the D orbitals there. We can draw other diagrams. You don't actually need to be able to draw the diagrams of the d orbitals. You do need to be able to draw the diagrams of the s and the p. So what that means is that if 2 electrons occupy each individual orbital, then for the total s subshell, 2 times 1, we've got 2 electrons that reside in that subshell. P subshell, we've got 3 p orbitals, each can occupy 2 electrons, so that's 6 electrons within that subshell in total. And then the d orbital, we've got 5d orbitals per subshell, which means it can reside 10 electrons in total. So this is where we really make the transition from GCSE to A-level when it comes to all these orbitals and the atomic structure, when we've got to define the electronic configuration. Because for GCSE, we tend to go 2 electrons in the first shell, 8 electrons in the second shell, 18 electrons in the third shell, so on and so forth. Whereas at A-level we can get way more specific because we can put those electrons within discrete orbitals. So we start by filling up the one shell first, and the one shell only has one s orbital in it. Then the 2 shell consists of the s and the p subshells. So we've got a maximum of 2 electrons that can occupy the 2s orbital, and we've got a maximum of 6 electrons that can occupy the p orbitals. Then in the 3rd shell, we've got the access to the s, p, and d subshells. Now, this is where it can get a little bit confusing because we fill the 4s orbital before we fill the 3d orbital, and that's to do with different energy levels. Don't worry too much about it. The key rule to remember is that we fill the 4s first but we also remove electrons from the 4s orbital first before we fill the 3d or remove electrons from the 3d orbital. And then it continues up like that. So when we look at our example for magnesium, from a GCSE electronic configuration, we have 2, 8, 2. Now this translates at A level is we've got 1s2, 2 electrons in the 1s orbital, 2s2, because we've got 2 electrons that can occupy that orbital, then 2p6 because we've got 3p orbitals, so 6 electrons that can occupy that 2p subshell, and then we've got 3s2. Okay, now we can do the same for potassium, but then we fill up from an A-level perspective 1s2, 2s2, 2p6, 3s2, 3p6, and then we come back to this rule, filling the 4s before the 3d, so we end up with 4s1. So now it's your turn. Have a go at manganese and gallium. Drop your electronic configuration for both GCSE and A-level in the comments, and I love to see how you get on with this.